Hello everyone. Today we will discuss about the basic of signal. In the signal section we have sampling. Sampling is very important for our DSP, which is digital signal processing. In signal processing, sampling is the reduction of continuous time signal to the discrete time signals. That means sampling works as the converter between the continuous time signal to the discrete time signal. In this diagram, we can have that the blue line denotes the continuous time signal, but after applying sampling, we can get those red signals, which are discrete time signals, and those are generated by sampling. In this section, you can say that here we have the analog signal, and those red points are the sample points. A sample is the value or a set of values at a point in time and or in the space section. Now the sampling theory. The sampling theory states that a signal can be exactly represented if the sampling at a frequency f where the f is greater than the twice of the maximum frequency in the signal. That means in this signal we have the frequency as here we can have that we have the starting point, and then the next starting point is the frequency 1. That means this is the frequency 2, 3, 4 and 5. In this section we have the frequency is 5. So if we need to sampling that on the theory of sampling theorem, we need to have the frequency f, which is where f is greater than the twice of maximum frequency. Here the maximum frequency is 5, so for sampling condition we need to apply the frequency 10, which is the twice of the maximum frequency. Now the Nyquist rate. In general, to preserve the full information of the signal, it is necessary to sample at the twice of maximum frequency of the signal. This is known as the Nyquist rate. That means the sampling theory and Nyquist rate are quite the same thing. But if we don't apply the sampling theorem, it means from this diagram we can have that we need to have the sampling of the frequency is 10, but in this diagram we have 1 2 3 sorry 1 2 3 and 4. Here the sampling rate is 4 Hz, but when we generate a signal from this sampling, we can have the signal which is not equals to the given input. In this diagram we have the signal which looks like this one, but from the sampling rate which is 4 Hz, if we generate by the 4 Hz, we can have the diagram which looks like this, which is not the original signal. So in this section, if we want to generate the original signal, we need to use the sampling theorem with the Nyquist rate. Now moving to the next. Now the part which is aliasing. When the signal is converted back into the continuous time signal from the discrete time signal, the phenomena is known as aliasing. Aliasing is the presence of unwanted components in the recontinuous signal. Those reconstructed signal, those components are not present when the original signal was sampled. That means we have the original signal which looks like this one. If we sample that signal at those rate and aliasing signal due to unsampled, that means if we don't use the sampling theorem and get the frequency not equals to the twice, then we will have a signal which is looks like this, and in this signal the signal is not at straight line and it have some zigzags. Those zigzags are known as aliasing in the signal format. The aliasing occurs when we convert the digital signal into analog signal. Now the sampling of analog signals. In this section we have xt, which is the analog signal, and xn, which denotes the digital signal. Here the value of n is from the minus infinity to the plus infinity. That's for today. Thank you.